Yeah, sure.
I have a question about the budget calculation. A component of this is a time component, right?
Time, yeah.
And how do you deal with different processors and this kind of thing?
Yeah, that's what I mentioned quickly. The idea is that you need the previous run in order to measure how long it takes for your particular Jack client to run on this particular platform where it's being deployed. I didn't mention power management as well. That's all another issue. I didn't mention it because normally what Jack people do is to disable completely power management before running the server. So I didn't mention it, but we have also a whole bunch of other papers and other works focusing also on power management, which also introduces a problem of potentially heterogeneous computing power available on the bottom, on the CPU, and how to deal that properly into the real-time infrastructure. So first of all, we need to benchmark anyway. We need some benchmarking points, any way we collect it. So either we run the platform a few times, or maybe in the first few times in which you run it, you really do some random assignments, or maybe you don't use the real-time scheduling capability at all. You run normally with the default scheduler, but at the same time you can benchmark anyway what is the computing power needed by the client. You can do that. And so once you record the parameters and you know, then you can exploit them later. That's one way. Another way may be a smart installer that for a real-time application, after the installation, a post-installation script, which runs quickly the core real-time part of the application on the platform where it's been installed in order to understand what is the performance for each, for example, for each configuration of the CPU frequency. There may be a possibility. Or you can run it only for the current CPU frequency and use an interpolation logic like a stupid linear interpolator for predicting how that can change more or less whenever your CPU doesn't run at 1 gigahertz, but it goes back to 0.75 or whatever else.
One question from IRC. Stefan Letz is asking, have you tried your system with any real-life applications like Ardor, not synthetic ones?
I'm not such an expert musician on Linux. I wish I could try some of these applications. They already show up with a graphical user interface that is impossible to understand. So the answer is unfortunately not. That's far too complex. If I start up hardware, I already have a headache. But I mean, I would be really happy to get some feedback also from this community if there were anyone willing to try. I mean, all this stuff is open source. The kernel schedule is open source. The modifications to Jack also. So if any one of you can provide any feedback on that by using a real application, it would be great.
Yeah. You mentioned highly dynamic workload like medicines and stuff. I think that's a pretty interesting problem. Do you already have some ideas how to tackle that? How would the cooperation between the application and the scheduler?
Yes, basically there's an idea, but no manpower so far to try to investigate on it, which is quite simple. As for example, in the fluid synthesizer, we really observed clear relationships between the number of active voices and the time needed for completing the cycle, for completing the cycle of the fluid synthesizer. You can simply, whenever you know that there's been an increase in the number of voices, you can simply try to communicate this in order to get a boost in the budget in advance, as compared to observing it later after an next run has already occurred. So the idea is that you touch the 10 keys on the keyboard, you get 10 more voices. This is immediately communicated to the scheduler, which boosts up the budget, and you are prepared for the upcoming, for what is likely to occur. But this needs a slight collaboration for the application. So there would be one of those cases which maybe we need one further API in the Jack API so that the application can exploit this API call only if needed, only if the application has really this very fluctuating demands. However, most of the applications, as far as I can see in the audio domain, are mostly tend to have to be filters or similar effects. So a lot of them tend to have a quite constant, let's say not constant, but I mean quite stable execution time. Yes, please.
Yes, you mentioned the problem with parallel applications. Currently, with Jack2, when we run parallel application in parallel, so to speak, we have problems because basically for one parallel application we run as many threads as many cores, but obviously when we have two parallel applications in parallel, we should divide that. So we need clearly a way to allocate the cores that each application can really use. So do you have ideas on how to integrate this aspect into your quality of service integration system?
Yes, absolutely. This it's a mobile window. Anyway. Okay, the problem you are raising is absolutely crucial in multiprocessor systems. This is just a picture that shows more or less what the real-time scheduler that we use can do, which is basically you take a computing platform along with the set of processors it has, for example, a quad core in this picture, and you can basically slice this computing power into slices. Okay, one slice is Q every P on each one of the cores, the other slice is Q2 every P2 on each one of the cores, and so on. However, our scheduler also allows different settings. You can also create a slice only on one core, or only on a couple of cores. So you can actually have a full control of what computing power you allocate and where. And that's exactly our plan to play a little bit with what happens when you have a kind of application like this, in which you may have a plugin that is identified as requiring a certain number, not only a certain budget every period, but also with a certain parallelism degree.